Problem 21. The two 7-digit numbers are each multiples of 3. That means the sum of the digits in each number is divisible by 3. And notice that A and B both show up once in each number. That means the subtraction of the sum of the digits in each number should also be divisible by 3, and by doing the subtraction, we can cancel A and B out. Here's how we do that. So for the first number, the sum would be 7 plus 4 plus A plus 5 plus 2 plus B plus 1. And we subtract the sum of the digits in the second number, that's 3 plus 2 plus 6 plus A plus B plus 4 plus C. And with the subtraction, we can cancel A and B out in both parentheses. And then we simplify the expression, we can get it equals 15 plus C subtract 19, and that equals C subtract 4. So now it means that C subtract 4 is divisible by 3. So from the answers, only A, C equals 1. That means 1 subtract 4 is minus 3. It's divisible by 3. The others do not qualify, so the answer is A. Problem 22. The two-digit number is such that the product of the digits plus the sum of the digits is equal to the number. So let's assume the two digits are AB. A is in the tens position and B is in the unit position, and the product is A multiply B plus the sum of the digits, that means plus A plus B. It equals to the number, and the value of the number is A multiply 10 plus B. So let's simplify this. We can cancel this A, and that means this becomes 9. And this B can be cancelled out. That means A multiply B equals 9A. Then B should equal 9. So the answer is E. Problem 23. The three numbers are all two-digit primes, and Brittany says the sum of Ashley and Catherine's numbers is the date of her birthday earlier this month. That means A plus C is an earlier date this month. And Catherine says, the sum of your two uniform numbers is the date of my birthday later this month. That means A plus B is a date that will happen later this month. So A plus C is smaller than A plus B. And Ashley says, the sum of your two uniform number is today's date. So that means we can erase this out. B plus C is today's date. So today's date is larger than earlier date this month and smaller than a later date this month. So from the first half of this equation, we can get that we can cancel the C's out. That means A is smaller than b. And from the second part, here, we can cancel the b's out. That means c is smaller than a. So we connect that it means c is smaller than a and is smaller than b. Because a month only has 31 days maximum, so we can consider the smallest two-digit primes first. That means the smallest three two-digit primes will be 11, 13, 17, and we can go one further, that's 19. And we can see that if we have 19 and 19 plus 13 is already larger than 31. So this can't happen. So the largest number in the three prime numbers should be 17 and the smallest should be 11. So because Kathleen's number is the smallest here, so C should be 11. The answer is A. Problem 24. To get the maximum possible median number of cans of soda bought per customer, we need to maximize the 50th and 51st customers' cans because the median will be their sum divide 2. And to maximum this, we should have the first 49 customers have as less cans of soda as possible. That means each one of them have only one can of soda. So that's 49 sodas for the first 49 customers. And 252 subtract 49 equals 203 cans left. And the rest of the customer will be 100 subtract 49 equals 51. And we use 203 divide the rest of the 51 customers. We get 3 and the remainder is 50. Now we can see that the remainder can be distributed from the 51st customers to the 100th customer. That means the 50th customer will have 3 cans and the 51st customer to the 100th customer will each have 4 cans. So the median would then be 3 plus 4 over 2 equals 3.5 cans. Problem 25. The road is 1 mile long and the width is 40 feet wide. That means the radius of the semicircle is 20 feet. And the diameter is 40 feet. Then we use 5,280 feet divide 40. That's how many semicircles we have. And the length of a semicircle, the arc of the semicircle is pi r. Pi multiply 20 is its radius. We divide 5,280 feet. That's how many miles of the total length of the semicircles. And again, we multiply the 5 miles per hour in the denominator. That's how many hours it takes to cover the 1 mile stretch. So we simplify this. Notice that we can cancel this out. And 20 divide 40, that's 2 here, and it is pi over 10. The answer is B.